Why is it saying waiting? It's having trouble. It says it's going. This is saying nothing's happening. Oh, okay. It is working. Okay, here we go. It's good. Okay, so I'm going to try to find this problem. Maybe about right there. Nope. Nope. How about right there? Oh, that's pretty lucky. Question is, okay, let me see if I can see what the picture looks like. It's like that. So it's got to be, oh, this is in the sections part. Let's go to, I think it was in this part. You're kidding, so is it not? Am I not seeing it? Wait, is it that one? No, it can't be that one. It's not that one. Well, maybe I'm blind. Okay, let's just do it anyway. Somehow I lost track of it, but I can select it, do a copy, make a new page, and drop it back down, and then we'll do it again. Although it's not very complicated, so it might be a little bit boring, but we'll go ahead and do it. So even though it's boring, we're going to try something interesting. And I'm going to use the snippet a lot. So in this particular method, it's something called, here, since I have the book up, I'll talk about it for a second. It's something called the method of sections. And what it does is it just arbitrarily goes by, and you can see this little section that he sliced through here. So he sections it, cuts it in half. I think he cuts it, so he cuts the left half away from the right half. Depending on which one you want to do, like in this one here, what's unique is that if I cut the left half away and go and just look at the left half, here I'll add a page so I can just talk about this. So if I go look at the left half here, what's interesting is I can come in here, hit the Alt key, get myself the drawing, I can come in here and pick this particular spot. I can look at the left as though it's an entire structure, and I can sum the moments about this point right here, equaling to 0. And if you're summing the moments, you have to decide which way is going to be right or left. So since this is 2 meters and then 2 more meters, I actually have, here, well, I did that right down here. Here, hang on, let me get rid of that glob up there. So the way I like to do it, since I can erase it, this produces a moment that way about that particular point. So that is a positive 1,000 because of that, and it's 4 meters because of that 2 meter and then the other 2 meters. Then you've got this one. That's the only other one you've got, and it's going the other way around C. So since I've designated it that way, it is 2 meters about. So you have to remember the transmissibility. I can move this force anywhere along its line. So I can move this one along its line too. So I can just move that 1,000 newtons to right there and forget about this one. Well, it's still 2 meters and 2 more meters. Hang on. So what I get is FGF times that 2 meters, puts 4,000 on the other side, divided by 2. And just like that, in a matter of seconds, you found out that that thing has 2,000 newtons. This force has 2,000 newtons. And so when you do that sections, you're looking at this, you could kind of look at this as though, treat this whole thing as though it's just one giant solid. And you may have internal forces there, but if you look at this as though it's just a giant piece of plate, and if you look at it that way, then what you're seeing is you're seeing all the forces that are put on that plate. And in fact, there isn't many. There's this one, this one, this one, and then that one. And that's all there are. And so once you get all that, once you figure that out, it becomes a fairly simple process. So let's head back to the other problem I had. No, this one. Okay, so the question might be, where do I want to slice it? I could slice it here, I could slice it here, I could slice it here. If I slice it here, that's pretty boring. And so I think what I want to try initially is this. Hang on a second. I'm going to hit the Alt key. Well, I may hit the Alt key, but I might really want to copy it. So I think I am going to slice it right here. So if I slice it right here, I can choose to look at the left side or the right side. The right side is pretty boring at that point. The left side might be instructive. So what I'm going to do is I'm going to use the eraser now, get rid of that, and then I'm going to use the snippet, snip the thing, and wonder what happens if I do that. I'll copy that too. And then I'll just put it right here. So, oh, it shoved that thing down. Okay, wait a minute. Is there a way you can do... Here, let me do this. Let me try to slice this thing again. Oh, it should be still in the clipboard. I should have thought of that. Copy. Copy to the clipboard. Now, how can I get away from this thing? I'll tell you what. If I go down here and put a mark down here, do a paste, it moves it down there. Then I can use this hand thing. Well, I thought I could.
That just moves the page, I believe.
Oh, does it?
I believe so.
Where is like a regular select thing? I guess I could just have to do a lasso select. That's stupid, but that's okay. Okay, here. Now, can I move it? Yeah, I can move it now. Good God, what did I do? I guess I moved everything. Okay, now get back to the pen. Okay, thank goodness. Okay, so now that I sliced it, there's a couple things that happen here. Once I slice it, I have to choose how, I have to assume a force. So I'll assume this is FBC. I'll assume that's, I'm just assuming the directions. FBD. And I bet the FBD I'm assuming wrong, but FDE. Now the next thing I do is I look for places that I can sum the moments about to make my life easy. So if I pick this one, that transmissibility means I can move this force back here, and it doesn't So this one doesn't produce any moment about B. If, though, it was up a little higher, it would, because I'd have a perpendicular distance there. But I don't. It goes right through B. So if I sum the moments about B equaling 0, and then say I'll choose that to be positive, then, okay, here's the other thing. That one goes right through there too. That produces no moment because it goes right through the B. So the only one that produces a moment is that one. That's great because that means one equation can pop out one answer. This doesn't produce a moment about B because it's going straight through there. So all I get is 6, and I'll just leave it as kilonewtons, times 1.5. So half of 6, that gives me 9 total. Half of 6 is 3, and then add it back. And then I got to determine, now see, I lost that in the translation over here. This distance is 2. So, again, this one produces a moment in that direction about B. This one produces a moment about that direction, B. So, in fact, that's a plus and this one's a minus. DE times the moment arm of 2 gives me FDE equal to, move the 9 over and drop the 2 underneath it, and I get that, or 4.5. So now the question is, since I did this a couple of days ago, I'm scared to go do it, but I'm going to go do it anyway. I wonder if I could slide this page above that page. Yeah, what's that one? That's that one. This is that one. Okay, did I get FDE last time being 4.5? Yeah, I did. Check it out. I called it ED, but it's DE. So I got that one. That was the 9/2. I don't know what happened there. That was weird. I wonder if it, hey, I better take that off. So I did. I got the same thing. Now that I'm on this one, what can I do next? Well, a couple things I could do. I can look at this, and you can look at this as a straightforward, rigid body, meaning that, and I'll make it yellow this time. So this whole object, just think of it as being some sort of plate, big steel plate, or if it's yellow, maybe it's something, I don't know. So it's some sort of plate right there. And all I have, I've got some loads sitting on it. I have this load, this one, this one, this one, and that one. That's all I've got. So now, what do I want to do? The easy thing to do would be sum of the forces in the y. And why am I doing that? Because I observe this is the only one of the unknowns that has a force in the y. And so just from observation, I'm like, I'm looking to do the quickest, correct thing I can to get the answer. That's all I'm trying to do. So I went for the moment first because I saw I could get rid of that because I saw 2 forces coalesce through B. That gave me that one right off. Now I'm looking for the next one. Now the advantage here of doing that way is that when I'm doing this next one, it doesn't depend on whether I did the last one the right way or not. So if I don't use this number in the next calculation, I don't propagate my errors through it. So sum of the forces in the y, shoot, I'll just make that positive. That makes that -6 and then -8. Plus, okay, now they got, look at this. This is 2 meters, and that's 2 meters. And I swear that's supposed to be 45 degrees, but that does not look like 45 to me. So it's not really to scale. So to me, visually, I don't know. Tell me this. Of course, this screen here is a different aspect ratio. Oh, it does look the same over there. That's weird. So I'm working on a screen with a different aspect ratio. So on this screen, it does look the same. On this one, it doesn't. Does it look the same on that one? Okay. Okay. So scratch what I just said. They are the same. It looks the same over there. I need to look at that screen more often. Okay, so it's 45 degrees. Okay. So if it's 45 degrees, I'm going to pull it over to the side. And if it's 45 degrees, FBD, then you get this component going that way, but you also get this component going that way. They're both 45 degrees, so this is FBD over square root of 2. And so's that one, but I'm not interested in that one quite yet. So that means it's FBD. It's very hard to work when you get to the side of the screen because the pen doesn't follow what you want it to. I mean, if you have these Surface tablets, they don't have that problem. The one I have at the house doesn't have that problem. If I get to the edge of the screens, it's as accurate as it is in the center. Okay, so what's 6 and 8? Isn't that 14? Move that to the other side. Is it 14? I think it is. So I get FBD equal to 14 times square root of 2. Now I'm a little bit scared now. I'm going to just use the calculator here I have in my hand. Okay, clear 14. Here, I'll do it this way. 2 square root times, what did I say, 14? 19.8. 19 point, I don't know. Yeah, I'll just stick with that. Okay, now I'm a little bit worried. Did I get that back over here on this last one? And I don't know how to do, oh, I can do that way. Okay, now how do I get rid of that? This way? Oh, okay. Crap, I forgot which one I'm looking for. Oh, I'm looking for this one. Oh, I was too lazy to do that number. Okay, that was the number 1. Where did I first show up with number 1?
Number 1 over dy. Go back down.
Go back down?
Number 1 over square root of 2.
Yeah, but I don't have dy, because then I found dy from there. I think it's over maybe to the right. I know what I'll do. Here, do it this way. Because I had these over here. When was I first? There's the number 1. Oh, God. I said, oh yeah, there'll be a number out of that. Let's see. Okay, it had to come out of this. Well, it could have come out of that node, but I bet it came out of B. Where is B? That's not B. That's not B. Here is B. Okay. So that was my number 1. So what the heck is that? Is that a 5 under there? Yeah, that's a 5. Okay, so my number 1 out of here should have been square root of 2. Okay, now what is 8 plus 7.5 times 4/5? Let's see. What is 7.5 times 4 divided by 5? 6! 6 plus 8 is 14. God, if I'd have just completed that. So I got 14. That's what I get for being lazy that day. It was probably late in the day. So I got 14 over square root of 2. Is that what I got on the other one? Oh, there you go. 14 times square root of 2. All right. So we got the same answer there. So there's nothing more to do there. Now the question is, if I wanted to find BC, if someone asked you to find BC and you didn't want to work hard, you didn't want to depend on this one, and you didn't want to depend on that one, there's a way you can do that. And let me use the lasso tool to kind of work my way through this. Okay, so on the lasso tool, what I'm going to do, I'm going to take this and I'm going to move it up here a little bit. But that's weird. Okay, take the, oh. Okay, well, let's delete that. I just wanted to move the force out of the way. Okay, and what I want to do is move this force kind of out of the way just a little bit. And then what I'm going to do, go up and hit the eraser tool, take these check marks, and then I'm going to recognize something interesting, and I probably have to zoom in order to be reasonable with this. And that is, even though a point doesn't exist on an object, you can still take a moment about it. In other words, this point right here, both this point, this force, and that force go through that point. Turns out that is the pin that sat right here. So even though D isn't on my slice, I can sum the moments about D equaling to 0. Now, why would it be beneficial? Because if I sum the moments there, this force has no contribution, and neither does that one. Does that make sense? So now, what does contribute to a moment about this D? Only that one, and this one, and that one. And so now I've got to start, tracing my distances. So in order to do that, I'm going to try to remove a bunch of crap and then come back and say, okay, I've got this spot over here, D. I'm summing the moments. I'm 2 meters times 8. And it goes this way around D. That's a positive. So 2 meters times 8. And then I got 6 meters, that's 3.5 over. And just like the other one, it's positive too. But what happened? Okay. Oh, I somehow changed pins. Okay, so it's positive 2, and it's 6 times 3.5. Last thing I've got is the thing I don't know, and it's 2 meters up. Let's go in the other direction. I could have just as easily assumed that the wrong way, and it would fix it for me. 2 meters up, FBC. Let's see, half of 6 is 3. 18 plus 3 is what? 18, 21, right? Is 6 times 3.5 21? And then I think that's 16. Add 1 7, you got a 2, 37. Huh. It's reconnecting. No data. Excellent connection. So if you're out there in the streaming world, you're not picking up all this. Okay, what did I get? Okay, I had to get this F CD, is that what I called it? Where did I do it though? Did I not get it? I don't know that I calculated it, did I? Because I see the sum of the forces in the Y. You know what? I don't think I calculated it the other day. I just left it there. So I didn't find that link. I did not find it. I found all the other ones, and I circled them and put the numbers around them. I left that one all by itself, and so I never solved that one. Oh well. So, I can't check it if I didn't solve it. Here, just out of curiosity. It wouldn't surprise me if the network's gone haywire here, or the computer. Let's see. I'm there. Who knows? It probably had a glitch. So if you look at the recording, there'll probably be a glitch in it. So at this point, what you'll find in the book sometimes is in these, so if you look at these problems, he goes through and slices things. There's one other thing that you might have to do. You'll have to see this. Now what we have in this picture here is essentially a hanging loop link. What I mean by that is if I slice this and look to the left, I have no unknown or yet to be determined forces. Now let's compare that to this one. Oh, where was it? Okay, compare it to this one. So if you look at this one, he sliced it from A to A through here. So he has to choose the left side or the right side. Don't know which side he's going to choose, but before he chooses it, he's got a problem. And his problem is, and I don't think I can write on this, but you don't know the reaction right here at A. You don't know the reaction at D yet. So what do you do there? You treat the whole object as though it's just a big rigid link. In other words, here, give me a second. Controlled. That's right, that. Okay, maybe it wasn't that. There we go. So if you take this object, go over here, say to yourself, I'm going to just basically treat this whole object as though it's a big, rigid plate. And then the question is, what is the forces over here? In other words, this one is pinned, so it can take a load here. This one is on a roller ball, so you've got a dy. Since this one is pinned and bolted to the ground right here, it can take a load this way. This one cannot. So since it's a roller ball, that object can roll back and forth over it. It'll only produce a vertical load. And so that's why they put these little roller balls in here. So you sit here and look at this thing, and you say, okay, I got an object here. What the heck am I going to do? Well, I can sum the moments about D equals 0. Make myself a positive. This load, okay, this will be AY, this will be AX. AX will pass right through that. So remember, the transmissibility was such that I can take this load, and the rule was I could take that load and I can move it anywhere along the action of the load. So I can move it to there, I can move it to here, I can move it anywhere as long as I don't move it up. So as long as I don't move it up, and I did a little bit there, but then so this can be treated as though the line of action is anywhere along its line of action, kind of. That was a weird way of saying it. So that means AX produces no moment. AY, on the other hand, does. It produces a moment this way, which is a minus AY 4, 4, and 4. Isn't that 12? And then this 400 produces a moment that way, which is a minus. I'm going to line them up under there. Okay, that's fine. Minus 400. And its moment arm was 3. You got 1200. Its moment arm is 2, but it's going that way. Wait a minute. That is a positive. Okay, go ahead and delete that. Positive 1200 times 4, and that'll give you your AY. I can tell just by looking at this, some of the forces in the X to this object tells you the only X force here and the only X force here, they have to offset each other. So I don't even have to, I can just scratch this out and say it's 400 immediately. So that's pretty much a given. AY, I don't know what it is. So anyway, I'm too lazy to figure it out, so he'll have it back over there. The only thing I don't have is dy. So then I know that some of the forces in the y, there it goes again. There must be something going on with this computer, because I think this computer is the culprit why it froze. So I got this one vertical, that one vertical, and that one vertical. These two have to add up to give me that 1200. So I can just write it down officially, AY plus DY minus 1200 equals 0. So after I find this number, I stick it in here, and then I can find that number. Once I have those three numbers, this one, this one, this one, then I can slice. You go back to the book. Oop, that's not how you go back. That's the first thing he did, is if you notice he did some of the force X first and determined AX was 400. Then he did some of the moment about A. He did A to find D. I did D to find A, but it doesn't really matter. So he finds dy of 900. Then he sums the forces in the y, recognizing that this, that, and that are the only three going vertical. So he says AY's got to be 300. Then, only after he figured out all those loads. Now, the thing is if this thing was hanging and I could slice it so that I didn't need to find that. Here's a typical case. Let's say we alter this and we have a different truss. Let's say our truss looked like, hello. Okay, I don't know what just happened there. Let's say our truss looked like this. Here's our truss. It's a bunch of members like this, sitting over here. And let's say, and this is on a roller ball. And we have a bunch of things out here. Say we just went nuts and we did that. Somebody loaded it, pulled it, pushed it. If I sliced here and looked at the left side, say this is 500, 1200, 800, and you know you have all your dimensions. If I look to the left, there's nothing that I need. If I look to the right, I have to find this load, I have to find this load, I have to find that load, which probably is going to go that way. So if you have these hanging trusses like this, where you can slice it and look on the one side of it, where you don't have a support mechanism, you can work the truss that way. So if somebody wanted you to say, what's the force in this member? Then, yeah, slice it right there. Or better yet, slice it right there. And work off of that, slice right through the member that you're looking for. That's why in the book he'll say, what's the force here in this member, and this member, and this member? He's telling you slice it right through there. You can find those three from that slice and you can get the answer. The fact that there's nothing on the left side of that needs to be known means you don't have to do this step that he had to do right here. Since he has a support on both ends, and no matter how he slices it, he gets stuck. Now, if he sliced it vertical, not say vertical, meant horizontal across this right here, he could get away without it. But since he sliced it here, he's got something left either on the left or the right he has to deal with. He apparently chose the left. I would have chose the right, but it's okay. He's got the 400, 300. He sums the moments obviously about C, and then you can turn around and sum them about G. So that's what he first did G, and then he secondly did C. Then he summed the forces in the Y, and the reason being is he's got to deal with that one, the F, or this one, or anyway, the FGC, that one. Well, I'm not having a good look here. So sometimes when you get really good at this, you can almost look at it and tell real quick where you need to slice it and get through it, and you get through it real quick. Most people who've done this stuff for years, and there's a lot of people that do this stuff in the world, you ask them, mostly they'll do sections, and then they'll do a follow-up with a node off to one side or something. So they'll do a section to get those forces in that section, and then if they need to crawl a short distance across away from that section, they'll do a node. So there we go. 8:46, I'm tired. We'll come back and do more. No, Friday, it's Friday, isn't it? We'll do the online session on Friday. If they ran the air conditioner more here, like if it was